This is Tobias DL3MHT, and as you can see, I did the insane and I bought a second TH-79E after my first failed repair attempt, trying to repair the display on my first TH-79E. So maybe let me quickly show you again and try to get it to focus. Not sure if that's working. Yep, so here you can see the botched up display of the first TH-79E, where I tried to fix the broken contacts here on the flex cable and failed. And luckily my second donor TH-79E had more or less an untouched LCD display. It still had the cursed blister on the polarizer, so I had to scrape off the polarizer foil again. Scary operation. Replace the foil, basically scrape it off, and with lots of API clean the glass of the LCD and then apply a new polarizer foil. And the result is that you get a quite greenish looking handset here. I think it's the thickness of the glue that is applied to the polarizer. So if the glue would be a bit thicker, it would not look as greenish. On the other hand, I have a perfectly working LCD display now. So let me maybe show you and let it focus. And I think you can see that looks pretty much perfect. So you think, hey, the guy is a happy bunny. He bought himself a second TH-79E and everything's perfect now. Unfortunately, that's not totally true, because as a test, I removed all the SMD capacitors on the second donor TH-79E and basically desoldered them and used my Peak Atlas. Don't throw it around. Peak Atlas is R70 to measure the capacitors, and the result, as can be seen here, are a bit overexposed. 1 second. Doop, 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 doop. Maybe you can read it now. Yeah, as you can see, all the SMD capacitors are basically bad, and a lot of them don't even read any capacitance anymore. So at least the hardware on my second TH-79E is completely bogged, and I would need to replace all the capacitors on that one. But that board has also other problems. So if I move it around here, you see here at the bottom, I attempted to repair the diode matrix. Somebody had a go at it and really butchered it completely. So to sum it up, my second donor TH-79E had more or less a nice housing. So the back and front housing was fine. The LCD display was fine. The diode matrix of that one was completely butchered. And all the SMD capacitors are basically dead. So that means on my assembled zombie TH-79E here, most likely all the SMD capacitors, and by SMD capacitors I of course mean electrolytic SMD capacitors, they are probably also dead. So even though the display problem is fixed and it also looks quite nice now. So this is basically the combination of all the best bits between the two handsets. So I've basically took the backside of the second TH-79E, which was less scratched than the first one, and the front of the second one, and the LCD display. I also polished the plastic here on front of the display with Displex, and it even has the wristband. So from, well, basically looking at it, it looks fine, but as you have seen here on the left side, since all the capacitors are dead, the likelihood that they are also all dead on this one are quite high. So I have to go through the pain of ordering replacement parts and then being brave enough to take this one apart again and replace the capacitors. So this has, of course, a risk of making things worse again. But before we do that, I thought I'll shoot a nice video in 4K and show you how the handset looks like and is operated. So then we have at least that as a lasting memory on YouTube if I screw up and things go really bad with the capacitor replacement. So first of all, let me switch it on and show you again the nicely working display. And also get the exposure right, maybe like this. And no, we don't want to reset everything. I just wanted to show you basic operation and hopefully not catch too much glare from my ring light. So as you can see, VFO-A is set to 2 meter band, VFO-B is set to 70 centimeter band. Well, the antenna that came here with the second handset is also the original. I think the first TH-79E that I got some different Kenwood antenna that was not originally designed or meant to be with the TH-79E. Well, let me just show you roughly how it's operated, and then we'll call it a day. So on the side, of course, PTT button, of course, tone button to send the 1750 Hertz tone for opening repeaters, monitor button, which basically opens the squelch, and a lock switch to lock all the keys. So if you have that on your belt clip and you have your clothes over it, you're not accidentally pressing any buttons so that frequency changes or it goes into transmit or some strange things happen. And that is a real manual switch that is soldered here onto the side of the PCB. So it's a micro switch with a little plastic doodad here. So I could imagine that these things might also go lost or went away, because there's not really, I mean, it's just clipped on, yeah. So this can fall off and then you lose your lock key. Okay, on the top we have the on-off switch, which is also the volume for band A. Let me try to focus once more. I hope this is all sharp. The first time I recorded, it was not sharp, so I'm recording this a second time. On the other side, we have the volume here on the ring to set the volume for VFO-B, and we have the rotary encoder to change the frequency. So this is a bit different than the TH-78E. The 78E had still a, well, symmetric layout. You had two rings here to adjust squelch for VFO-A and B, and two volume knobs for, well, VFO-A and VFO-B. So this is somehow in the middle, in the transition phase from, well, how should I say, traditional Kenwood layout to a more menu-driven system. And the F7E, the Kenwood F7E, is then the next evolution step, I would say. So this is somewhere in the middle between traditional operation, where everything is basically a special key combination, like, I don't know, enabling, disabling duplex mode, setting your DTMF or CTCSS frequency. That this is all still special key shortcuts here, but the thing already has a menu. So when you press menu, and you can use here the rotary switch to scroll through the menu and, well, change less often modified settings. And the more often modified settings that you use daily, they are still on traditional function keys. Yeah, and I think the TH-78E was even worse in that respect, because it did not have buttons which had 2 functions. They already had 3 or 4 functions. So depending whether you press the F or a F square button, or press and held a key and then pressed another key, you could basically have each of these numbers here on the keypad on the TH-78E had like 3 or 4 different functions. So it was really, I mean, you really would need to be very familiar with your handset or have read the manual very carefully to remember all of that. So this is already a lot easier to use than the TH-78E. So maybe let me just walk you through some basic features, and then we'll call it a day. So band change is, hey, press the band button, and you can see when I press it here, and the PTT icon jumps from the bottom to the top and back to the bottom. Changing TX volume is equally easy. So you just press here, and it goes from high to low to extremely low and back to high. This is, of course, changing the power of the currently selected band. So now I'm at 70 centimeters and set the transmit power to extremely low. Now I change the band, and you see it says high. So 2 meter is still transmitting with high power. Pretty easy and straightforward. Setting the shift is equally easy. Press the shift button, and you see this plus or minus showing up next to the 2 meter frequency. And that way you can basically set a positive or a negative shift. And for the 70 centimeter band, you even have a positive shift, a negative shift, and a very negative shift. And the double minus gives you the minus 7.6 megahertz that is used in Europe or in Germany for your repeater offset. If you press the ref button, as in reverse, you see that it jumps down this 7.6 megahertz. So by just pressing this button, you can easily verify if you hear your QSO partner on the input frequency of the repeater. And if you do, you can switch to a simplex frequency. What else? Dual. Okay, of course you can switch to monoband operation. So now we are on 70, now we are on 2. Or you can have 2 meter and 70 centimeter receive enabled at the same time. And of course you can also press F and dual and go into duplex mode. And I think the duplex mode has even 2 different modes, because there's one mode where duplex is constantly on and one where duplex is blinking. So I'm not sure what the second one is. That would be a case where you would have to look into the manual again. What else? Yeah, setting the squelch. This one has a digital squelch, so you press the squelch button and you can use the rotary encoder to adjust your squelch in 5 steps per band, of course. Then it has this rudimentary or initial menu system for rarely changed settings. You also can press F and menu, and then you get a status report of how the thing is currently configured. Not sure if I would have wasted a extra key shortcut to that, but Kenwood did. And another nice thing is you even have a short guide. So if you press F and SQL, where it says guide above, then you can use the rotary encoder, and it gives you a tutorial of frequently used functions that you maybe cannot remember because you didn't bring your manual. So like, how do I how do I do a VFO reset? How do I do a complete reset? How do I do a clear a memory channel? How do I transmit a DTMF code, etc., etc. So for a few functions that might not be completely obvious to you, you can here look up and see, hey, how do I do a memory scan? Memory scan, press the memory key for longer than 1 second, and then it starts a memory scan and so on. I think that's a nice idea. That they have implemented something like that. Okay, maybe let me try to show you the backlight. The backlight is pretty dim. So first let's switch off the light here. And you don't see anything until I crank up the ISO. And this is as bright as you can see it here on my camera, which is still underexposed. Try to get closer and focus. No, yeah, that's not working. Yeah, as you can see, it's not very bright, but if it's pitch black around you, it's bright enough. Okay, what else do we have? Yeah, on the other side, of course, we have the slot for the CTCSS module, which was still optional at the time. Microphone and speaker, well, usual Kenwood input here, and the DC input for charging. And the battery is of course not an original battery, it's some aftermarket battery that I got out of China. And the odd thing is that battery also came with a charging pin here, and the dangerous thing is it is exactly the same size as the usual Kenwood 13.8 volt connector, and I'm pretty sure when you put 13.8 volt straight into that battery, it will not be happy. Yeah, so you should probably use a nickel metal hydride charger and give it 7.2 volts or something like that. Okay, yeah, here we have a few more buttons. A megahertz button to probably, yeah, quickly change the megahertz. VFO and memory button to switch between VFO mode and memory mode. I have not programmed any memory channels here yet. And what else? Yeah, okay, of course you can change the step function. By step I mean the raster. So 12.5 kilohertz, 5 kilohertz, whatever, when you use your rotary encoder here. And well, a lot of other functions. I don't think we have to go through everything. But I think you got a first impression and at least basic operation, setting a frequency, repeater, and even setting up the CTCSS tone is pretty easy. You just press F and 6, and here you then go into the menu where you can change your subtone. And the subtone can then be enabled by pressing tone, which makes this little T icon show up. And when the T icon shows up, then it transmits the subtone. I'm not sure if this already can also filter for the subtone on RX. So if that the squelch only opens when the certain subtone is present. I have seen that functionality on the Kenwood F7E. I'm not sure if the TH-79E already had that. I think maybe not. Okay. So that's it for the moment. As you can see, things look good at the moment, but there's still some work ahead of me, and things can of course go wrong when I make a mistake in taking off the capacitors or soldering it on or make a short, or there's damage under the PCB, which I don't know. So for that board, I was able to take off all the capacitors, and the PCB still looks pretty good. I think I cleaned up some goo. I'm not sure if that was leftover flux or if it was already leaking acid from the capacitors. But if I'm lucky, they dried out without leaking. So that's my hope now, also for the second device. that the capacitors in that one are also dried up without damaging the PCB. Okay, I'm already talking for 20 minutes. It's really time to end this video. Thanks for watching, and until next time, wish me luck with the hunt for the right SMD components. Bye!
Please like and subscribe.